So good evening, our two valued guests, and Brian especially, our speaker this evening, and Emily, as always, thank you for helping out. This is our second virtual meeting at freeCodeCamp Barrie study group. I had to beg Brian from the BRIX works, and I'm just going to post his group's website. He has a nonprofit. I did have this ready to go. Here it is. Facebook Made in Barrie. Is that correct?
Yeah, Made in Barrie is the Facebook group for the Makerspace. Yeah.
All right. So, if you're curious what his group's all about, they're trying to find a home to do all this fun stuff in person, and I suspect that maybe they'll do some online stuff until then. He was kind of floating that idea. So, I thank Brian for showing up this evening and showing us soldering basics and some other fun stuff. I wanted to start this evening. I've been thinking about this story for a long time. I wanted to start this evening with a little story of mine. I just finished graduating from college, and I started my first job in a data center. And me and this other guy were waiting for our training. So we basically sat there and surfed the internet all day. And that got boring after, day 3. And so we started like having these wacky conversations back and forth about, what we just learned. And he turned to me and he said one day, it's funny, I graduated from this computer programming course at Georgian College, and nobody ever explained to me how a computer works. And I was kind of like, huh? I said, what are you talking about? And I was a little dumbfounded by the simplicity of his question. And he challenged me. He said, okay, go ahead. Explain to me how a computer works. And so then I started. I'm like, okay, well, we have these peripherals and they hook up to the CPU. And he's like, uh-huh. And how does that work? And then I started giving him like talking points from our operating system class. I was like, oh, well, the operating system swaps things out of the memory and this and that. And he's just like, uh-huh. And how's that work? And how's that work? And he just kept boiling down till he stumped me. I got to a point where I said, well, the motherboard takes electricity and does something. And that's how, and he's like, aha. He's like, exactly. He's like, how does, plugging it into the wall translate to all that other stuff you're talking about? And a lot of it is the fundamentals, which I hope we'll maybe touch on this evening, maybe not, but it's the simple hardware. It's learning how to play with that simple hardware and then expanding that knowledge to the point where we can do complicated things. So I want you to think of that story. Even though I had graduated, became a super user, I still didn't know the fundamentals, which is how do you get electricity to do all this fun stuff behind the scenes. So with that in mind, I brought in an expert in the field of getting us started. So, Brian, it's McGillis. Is that how you spell it?
That's correct. Yep.
McGillis. Okay. So, Brian McGillis, everybody, big round of applause. We thank him for.
I have no face camera today, unfortunately.
It's fine.
So yeah, my answer to that is the magic of transistors. That's how the electricity goes to logic. But anyway. Yeah, so as you were saying, I'm part of a group that's trying to build a makerspace in Barrie, and I was part of a group called SimcoLab, which was already doing meetings, but sparsely, like not very often, and not a permanent space and all that kind of stuff. But we're trying to do the big goal of actually having a full makerspace in Barrie. So I'm sharing my screen now. I'm going to stop the share at the, well, actually, you know what? I'm just going to move over to this guy so we can start our soldering thing. So soldering. For those in attendance, I'm just kind of curious about if you were to solder, what kinds of things do you expect you would soldering? Or are you just to the point where I just want to know what it is? I'm not sure what I would use it for or that kind of thing. Does anybody have any feedback on that? I can offer some possibilities if we don't have any. So,
well, yeah, okay.
Yeah.
I'll open the floor so
Sure.
other people can chime in. I have a flat screen TV of ours that it makes a squealing noise, and so I Googled up how do you fix a squealing noise, and it said you open up the back, you see if there's any loose capacitors or stuff like that, and then you resolder them on new parts. And so that was a project that's been sitting in the corner of this room for months because I just don't feel confident.
Yeah, so repairs are a big thing. Yep, I did that with a rear projection 50-inch something TV a few years ago. There was some kind of decoder chip or something like that that went. And my wife's like, you know how to solder, you can do this kind of stuff. And I'm like, yeah, but it's a big, huge pre-T. But sure enough, ordered the part, unsoldered the bad one, put in the new one, and it had another year life in it. So repairs is a big one where it's $1,000 thing, and for the lack of a blown capacitor or resistor or whatever, because that particular one didn't have a high enough tolerance for the stuff that went through it, or maybe you got a power surge or something like that. Repairs are definitely a thing to use soldering for. Other big things are so I would say, first of all, kits, like putting together kits. So if you order, and I'll go to my video. You guys seeing the desktop, my camera video now? So you can get kits, and so this is an already assembled one that I got at a maker conference that was in Toronto a few years ago. And so this is just like a simple little raccoon with LED eyes, and then you can get into more complicated stuff like this is an Arduino clone, like a mini Arduino clone, and it comes as a kit with these header pins separate, not soldered on. So I believe I had one over here. But yeah, I have separate header pins that where was, oh yeah, here's the header pin. So these pins are what allow the all the signals to connect to wires and that sort of thing, or plug into things, or use hookup wire like this kind of thing to hook the Arduino to other devices and that sort of thing. So doing kits is a big thing, like being able to assemble stuff, because it's cheaper. And also you can make modifications. If you get a kit, it comes with LEDs and you might want to put super bright ones on, or that kind of thing. So that's one thing. And then another thing is just plain old building your own circuits. So from scratch. So typically you would start with building a circuit with something like this, which is called a breadboard. So these rails up here, these two long ones are connected at the top, these two long ones are connected at the bottom, and then these are all rows that are connected except split in the middle. So this is where you would use these wires like this to, or the wires like this to, like, prototype a circuit, so to figure out if something worked. And you can put chips across the middle like that. So it's all purpose built for this type of thing. And then once you figured out how to hook it up and it worked, then you move to this kind of thing, where you can further prototype it on an actual circuit board, actual type of material, to either be permanent just on that, or to prototype it further on an actual board, because there's actually a little bit of difference as to how things can behave between a breadboard and a circuit board. So yeah, building your own circuits and assembling circuits are another couple of things. A third thing is kind of along the repair route, is connecting wires together. So say you had an extension cable, or some sort of a data cable or extension cable you wanted to make, and you just wanted to make it longer. So I don't really have an example handy, but just splicing wires together, or if you get a frayed wire and you want to solder it together, that's often something that soldering comes in handy for. So go back to sharing my screen. Desktop 1. So this is a handy little guide I found on the basic solder, and it has a lot of the things that I would recommend, and I'll give you guys a little bit of flavor as we go through. So soldering itself is basically just low-grade welding, essentially. So you're actually physically making a kind of like a welding connection between two pieces of metal, and you're using solder as kind of the glue. And in normal welding, you use wire or welding rods or something like that to be the glue between the two things, and you're trying to make a really good electrical connection. So what this diagram is showing is that typically what you want to do, the biggest thing with soldering is that you need to get heat into the things that you're soldering. So one of the most frustrating things that you can have with soldering is that you're trying to get the solder on both of the things that you're connecting, and you want the solder to coat them both. And the stumbling blocks that you can get into is that it doesn't connect to everything. It doesn't stick to it. It forms this little ball on the wire instead of flowing nicely onto where you're trying to connect it. And that's really a lot to do with the heat transfer. So, soldering irons are kind of like little needles or pens, and it can be tricky for beginners to, um, get the experience or just, do it. The first few times you do it, it's just a matter of, you could put the solder on here all day and nothing's happening. And there's certain reasons that can happen, and we'll work on getting through that. So soldering tools, obviously, biggest thing, soldering iron. There's a bunch of different types of soldering irons. You can, with a lot of these kinds of tools, you can start very basic. A pen soldering iron like this that's just got one heat setting on it, and for a lot of the basic stuff, this will do the job. It might be a little more frustrating to work with in certain cases, and it might not be able to handle certain kinds of situations. But for a lot of stuff, just having one of these handy for a lot of projects will get you going for quite a while. And once you get the experience of doing some soldering yourself and getting some projects under your belt, you'll it'll become very obvious to you if and what you'll need as far as a soldering upgrade. So these are more complicated soldering stations. The biggest thing about them is that they have temperature control. So um, one big thing about this, like I was saying, getting heat into what you're trying to solder. If you have a little soldering pen with not a lot of power into it, it's going to have trouble kind of like pumping heat into this, because one of the key concepts you want to remember is that when you touch this soldering iron to anything, this is going to suck the heat away from the soldering iron. You kind of don't really think of that necessarily, by default. It's just a matter of, um, you think you touch the soldering iron to something and it's instantly going to be super hot. But you kind of have to keep in mind that there's all this heat transfer stuff going on, and if you keep that in mind, it can minimize some of the frustrations that you have. Um, so if you have a temperature control, it allows you to increase the heat, decrease the heat. For more delicate stuff, you can decrease the heat so that you don't end up damaging components. Or if it's something that's bigger and the metal that you're connecting is bigger and it will draw more heat from your iron, you can turn up the heat. And also the other thing is just how much power it has. So like one of these kinds of irons could be like 15 or 30 watts, where you can get ones that are 100 watts or more in a soldering station. And what that allows is that as you're soldering and it starts to draw the heat out of your soldering iron, it can keep up more. It pumps the heat in faster, so that it's not like uh, you know a drop in temperature of your soldering iron tip. It'll keep it at that temperature, which makes things a lot easier to work with. The tips. So this is another thing that's about the heat transfer, and also about the applications for different type of things. So you want to use the biggest tip that makes sense generally, because the bigger the tip is, the more mass of metal you have here, and then there's more heat held here. So when you put this on something, um, the temperature drop, the heat shock you would call it, isn't so great, because you've stored up more heat in this metal essentially. If you've got a little tiny tip here, then first of all, you don't have as much surface area to touch the things that you're soldering, and and so there's less surface area for the heat to transfer through, but also there's just less metal here holding heat, kind of like just a bucket of heat. It just runs out faster because there's not as much metal there. So a chisel tip like this is usually very good for most applications, like a medium chisel tip, medium to small chisel tip. This would be for very, obviously very small things. Um, can get frustrating to get enough heat transfer with something like this. And this is for like big, huge copper pads that you've got where you need to transfer a lot of heat into it. Sometimes pads on circuit boards will be used as actual heat sinks. Like there'll just be a big copper pad on a circuit board, and there is no separate heat sink. It's just a big pad, which is enough to do the heat sinking in a circuit. And they can be often hard to solder to, because they just keep drawing the heat out of your soldering iron, and it never gets hot enough to melt your solder. So tinning the tip. So um, I don't think they haven't covered that yet. But the big thing about using sponges and uh, steel wool. Oh, this is made of brass. Brass sponge they call it here. So these are for just cleaning the tip of the iron. So I'm going to show you the tip of my iron right now. And I think they have this later on in the guide, but I'm just going to show this to you right now. So I've had my soldering iron for a little bit. I was practicing a little earlier, and I'm not sure how easy it is to see, but this is kind of like a small to medium chisel tip, and it doesn't look very shiny at the moment. It's kind of got a little bit of oxidation on it, and oxidation is something that happens to a lot of the different things you work with in soldering. So like the soldering pad will have oxidation on it, your soldering tip will have oxidation on it, and then I've got one of these, like the brass sponges that they were showing in the, here we go. And so, and I also have one of the sponges too in my soldering stand that you can't see off camera, like this. So you can, wipe the soldering iron on here. I mean, you just leave the sponge in the holder and you just wipe it like that, but to get it to the camera. So now I don't know if it's coming out on the camera, but this is a little more shiny. And so that will help the heat transfer, because the oxidation gets in the way of the heat transfer. It makes the surface bumpy, and also the oxidation material itself, the oxidized metal, doesn't transfer heat as well. The brass sponge I found is quite a bit better at cleaning it. So you just basically scrape it. It seems bad, like you might be damaging the tip, but it's not that bad. It doesn't really damage it. So, and it's made of brass, which is a nice soft metal. So that will get you a nice clean tip. And when you get a brand new soldering tip, I've got a new one over here that's for like the pen type of soldering iron. Let's get this one out. This is a brand new tip, never been used, just out of the package. And you can see it's just bare metal, like it hasn't been used for anything or done anything with. This is for a basic pen type one. If you get, you can probably see it on here. There's a little bit, this is for a slightly better Weller brand soldering iron station with a control that is over here. They have a little bit of different material down here that helps with the tinning process, so that these tips are a little bit better. But even with a basic one, you'll get it like this. And what you'll want to do is, the first thing you do is you scrape it off or wash it off, and you get solder on there. You just put solder on it and coat it, and that prevents oxidation from getting on here as well. And also the solder, because you've got a thin layer of solder on your soldering iron, it makes it much easier to transfer heat to the things that you're soldering. One thing about the sponge, a little bit with the not the brass sponge, this sponge. The one thing about this is that in order for this to work, you have to put water in it. And then when you're soldering and you clean the soldering tip on the sponge, you actually end up draining heat out of your soldering tip. So I usually like using the brass sponge because it doesn't really drain the heat that much. You're just kind of like scraping it off, kind of sort of thing. But when you use the water sponge, it can drain heat out of your tip fairly quickly. And if it's a small tip, then it can make things a little bit frustrating if you have to wait for it to heat up after every time you do this. Also, it can be a little bit bad for the tips if you heat shock them a lot. So soldering iron stand, this is just a plain stand with like one of these sponges underneath. You need to put it somewhere. Most soldering stations come with one, obviously, but if you have just like a pen stand, soldering iron, it's good to have a stand on its own. Solder. So obviously you need solder. So you cannot use, first thing is you cannot use plumbing solder. Solder for electronics and plumbing is completely different. Not completely different, but it's got differences in it that make it not suitable for electronics. The big thing about it is that solder has something called flux in it, usually, which is a convenience thing. And the flux that's used between plumbing and electronics is different. The plumbing stuff will damage electronics. So solder itself is used to be made with a lead tin alloy, essentially. And because of the obvious health risks of lead, they've moved to other types of alloys that don't have lead in them. So lead-free solder is what they call it. Lead-free solder is a little bit harder, however, to use. It doesn't melt quite as easily. it has a higher melting point, so you need a hotter iron to use it. Leaded solder is okay to use, but you just have to be aware that it's the kind of thing where you're going to want to wash your hands after, just to be absolute sure that there's no risks there. So yeah, so solder is important. You almost always want to use rosin core solder because it has the flux inside it, so you don't need separate flux. Do these guys go over flux? I don't think they do. Okay, so flux. Flux is extremely important in soldering. So what flux does is it's kind of just like um, a cleaning solvent essentially. So the solder, it's the flux. They impregnate. They basically have like a core down the middle of the solder with some flux in it, so that when you melt the solder, the flux just flows out and flows onto the joint naturally. And what it does is the two major things are it cleans the very outer surface of all the components that it touches, which makes it easier for the solder to stick. And also it has an effect on the surface tension of the solder so that the solder will stick to the components better. The heat also has a huge impact on that, but the solder does, or the flux does have an effect on that as well. Helping hand. So this is kind of something that a lot of people will try to use when they're soldering, because just pure numbers, you have to solder two things together, and you have to hold the solder and you have to hold the iron. So there's potentially up to 4 things that need to be held: the thing that you're soldering, this thing you're soldering it to, the solder, and the iron. So it's almost essential, not really, but I mean, it's going to make your life a lot easier if you have something like this. There are a couple of different types of them. I'm going to show you a couple that I have. So you've already seen this guy. This is a circuit board mount. So if I want to say put an LED in here, I can put this in through the back, because obviously the pads are on the front of this thing. Let me get I have another. This is a one-sided proto board. So there's pads all on this side. You can get ones that have strips that are connected together, kind of like the same layout as a breadboard. So if I wanted to solder onto this, I would just put things in through the back, because I'm going to be soldering it to the pads that are on the front. And then so that I don't have to hold on to the LED, I'm just going to flip the leads like that. And you could do it both the same way, but then you get this action where it flips back and forth like this, which isn't good. So usually it's better to flip them opposite directions, and then it will more or less stay in place. And then you can solder to the pads there, and then you're good to go. So this would be kind of difficult, without the holder, but this kind of stuff is possible. When you get started out, you can just lay it on the table, solder it like that, and you're good to go. So long as it's a component that isn't going to wobble around on you like very much, and you can use those leads to hold it in, you should be pretty good. There's also one thing that you can use is if you can use just plasticine or putty. Certain types of things that you want to solder, you can just plug just push the component into here and hold it. This is really old putty. But if this some kind of weird situation where you just need something to hold it, and it's these things can't be used, it just won't do the trick you need to do, then you can use putty sometimes to just hold something for you. And any just everyday kids plasticine will work for most applications. So let's put this guy back here. Magnifying glasses on this puppy. So some things are really, really small, and it's easier on your eyes and that sort of thing to be able to just magnify things. I have the full like Ghostbusters Egon Spengler head-mounted thing with a light in it and multiple magnifications and stuff. Head-mounted gear kind of thing. And I also have a couple of jeweler's loops that I can just put in my eye and look at things a lot closer. Sometimes there are markings on, if you get a kit, there's like, this resistor goes in this hole kind of thing. And it can be hard to read those sometimes. So a jeweler's loop is a handy tool, or something like this, which is just like the jeweler kind of magnifying glass with the built-in light. So that can be very helpful. Safety stuff. So hopefully you're not soldering in a way where anything gets in your eyes, but if you're clipping leads and that sort of thing, stuff can happen. So it might be good to keep a pair of these around. And then when you're soldering the resin, the flux, which is basically made of like, you can make it out of pine cones, like it's like tree sap sort of kind of stuff, refined obviously, but it smokes. So if you're doing a lot of soldering, it can get irritating in your eyes. If very often you're soldering and your head is directly over what you're soldering because you're looking down on it. So having something to a filter with a fan on the back to pull the solder, the smoke away from you. The solder itself, like the metal, like the lead in the solder isn't going to get to you, but the flux can be a little bit annoying and not good to breathe in long term, really. So here we're talking about tinning the tip. You attach the iron, make sure it's really, really well attached, because there's a heat transfer between the iron and the tip as well. So if this is loose, and not contacting the inside of the iron very well, then you won't get good heat transfer and it won't heat up very well. So you get your tip in, and then heat up your iron fairly warm on the high end. Clean it off quickly, and then just put solder on it. And then the flux in the solder should help it flow around the tip. And as long as you keep it pretty shiny and wipe it fairly often while you're soldering, basically like most people who do soldering consistently, it's kind of like a habit. After every time you attach something or whatever, you wipe it first and then put it back in the holder, or every time you pick it up, you wipe it first and then solder. So it's almost like every time you solder something, unless you're doing a bunch of things in a row, you generally wipe it quite a bit. So here we're going through mounting components. So you can see that there's pads exposed here. Bend the leads so that you can get to it. Put the solder on the other side. You don't want to touch the solder to the soldering iron if you can help it. You want to warm up the pad and the lead to a hot enough temperature to melt the solder on their own, because what that does is ensures that the pad and the lead are hot enough so that when the solder melts, the solder will stick to them essentially. If you have cold leads or cold pads and just melt solder and drop it onto it, it'll just stay like as a water bead. It won't stick to it. So you really have to get it warm, and then get the solder to flow and stick to it. Sometimes you can cheat if you get it warmed up and it for some reason just won't flow. Sometimes if you touch the soldering tip to the solder, and then because the melted solder can then help heat up everything a lot better, because it can flow around and transfer the heat to a lot more places. Sometimes that can work, but you'd like to try to avoid that if you can. This is also why a chisel tip can help you, because it's got a wider tip. If it's not like a point at the end, if you have a wider tip, then you have more surface area you can get in contact with everything in order to transfer heat to both of those things. Snip the leads after you're done. It's not really a good side look, but you want the solder, when it's done, you want it to basically like stretch out to cover the whole pad. And it'll look kind of like a volcano. It'll have curved sides, and it will stick very well. If it looks like a ball, it's probably not a great joint. And you would have to remelt it and try and get it to stick, or remove the solder entirely, which we'll go over and try again. So this is about connecting wires together. Basically, you tin one wire and then solder the other wire to the tinned wire, or you can tin them both and then kind of stick them together. This is where having something to help you hold things is really, really helpful, because soldering two wires hanging in midair is not easy. There are various things you can 3D print as well, if you have access to one that allows you to like hold wires, especially for this type of thing. So that's good. Desoldering. So repairs. If you're repairing something, you have to get the old thing out. There's a couple of main ways of getting solder off of a joint. Soldering braid. So you basically just heat this up and it's like a sponge. It will just suck up the solder off of the joint. And because this has a lot of, it's like a like metal fabric sort of kind of thing. The solder will be absorbed by it, because it's, like I said, it's like a sponge. So you basically just heat it up, wipe it over the spot where the solder is. You can use it to, if you have like these circuit boards are through hole circuit boards, there's actually a hole in it the lead goes through. You know, if you have solder that's inside there, you can use the solder braid to get that solder out fairly well. So, and then you just like wipe it over that, or you could use it to get solder off of a joint as well. The other one is a solder sucker. So I have one of these here, and I'll just show you quickly how it's operated. I won't take any solder off quite yet, but you basically, you know, it's just a vacuum. You just push this plunger down, and then you hit this button, and it just you know, pulls the air in really, really quickly. So you would just heat up the joint, make sure that wait till the solder is liquid, and give it another half second or second to make sure that it's nice and warm, and then hit the button, and it'll pull all the solder into here. And then you basically take the cap off, and the little bits of solder will fall out. So I use that usually. There are more complicated and professional ways of doing that kind of thing. They have desoldering guns that basically are like a solder sucker with like a built-in vacuum pump and like a round tip that just goes around the joint. And you basically just, you know, put it on the joint, pull the trigger, wait a couple seconds, and all the solder is gone. So yeah, removing solder is you know, you'll have to do it eventually, either for repairing the joints that you're making on your own, or for you know, doing repairs, or one other big thing is that salvaging parts. So if you get old circuit boards and that sort of thing, if there's stuff on there that you want, you know, you can pull off you know, transformers and you know, there's a bunch of things that could be useful in your own projects that you can get out of you know, essentially junk essentially. So you would want to be able to get the solder off of those types of things. So that's so those are the basics. I'm gonna go and do a quick demo here of actually doing some soldering, and hopefully this won't be too embarrassing, because I haven't done it very often. So I've got my my iron's been hot for a while, like I said. I'm going to be using just a tube of solder like this, and it's nice and convenient because I have the tube and I can hold the tube, rather than something like this. You can use it fairly well. It's just a little more awkward. You can see this solder is a lot thicker. Would be better for bigger you know, bigger joints and that sort of thing. This is a pretty small joint, so I'm just going to use the smaller solder. So I'm going to start with an LED, nice and easy. So I'm not sure how much experience people have with electronics, but on an LED, there are two legs with different lengths. And an LED is a diode, which means the electricity only goes through one direction. If it goes through the other direction, it will either not flow or it will burn up if there's too much electricity going through. So you just make sure that you know which side is which before you put it in. So we're going to put this in the back. I might have to take this out to get it through. We'll see. I'm just going to turn it this way, which is, this holder is very convenient for that. Just put it through like this. And
sorry, Brian, what's a diode? What's a diode do again?
A diode.
Diode.
A diode is an electrical component that only lets electricity go through one direction.
Ah, okay, thank you.
So an LED is a light emitting diode. So you put the electricity through the correct direction and light will come out. So yeah, you have to, yeah, you just basically have to do it. It's a you know, certain components, the polarity matters, certain components it doesn't. Certain capacitors you can put them in, there's no backwards, but I believe I have, like, so here's what you would call an electrolytic capacitor. So you can see there's a minus sign on it. So you have to, one second. So there's a minus sign on this, which means that this is the negative side of the capacitor. It won't work the other way around very easily, or you know, it just won't work. So a diode is a you know, polarity, a device that polarity matters essentially. So we're gonna try this puppy. So you know, this is not like, you know, the world's, you know, fanciest schmanciest proto board. The pads are not huge. But we'll do our best here. So I'm going to put the chisel tip, and that's not super shiny, so I'm going to give it a little wipe. And actually, it's been a while, so I'm going to actually tin it again. So we're just going to put some solder on here. It melts pretty quickly. You can see all the smoke, and that's, like I said, not from the metal, from the rosin. Thankfully, due to my hastily assembled camera setup. My face is nowhere near that. So we're gonna pull some solder out of here just so I have some, you can bend it however is convenient. And I've got a chisel tip, so I'm gonna put the chisel like so. I'm gonna let it heat up, say 1, 2, 3, 4 seconds, and I'm gonna feed in the solder from the other side. And when it heats up, it will start to melt. And sometimes you have to put some pressure on, there you go. And then take it off, and that's it. So the two sides of soldering of you know, the too much and the too little. So if you don't hold it there long enough, you're not gonna get enough heat. If the solder melts and things aren't hot enough, it won't connect properly. You know, it might coat, you know, the component or the pad, but there won't be an electrical connection or a very good electrical connection. They have something what's called a cold solder joint, which means that the surface of the solder that's facing the thing you're trying to connect to has actually solidified and isn't really touching it, or is touching it so gently that not very much electricity is actually going to get through. So let's do the other side of this one. Where's my chisel? My chisel is, I'm going to actually wipe this off a bit because there's a little bit of residual solder on it. So we're going to heat up this joint like that. I'm going to push down a little harder this time. And then we're going to feed some solder in once it heats up. So then once the solder starts to flow, he'll hold it for a tiny bit and then pull it off. And that's it. So yeah, it's not too crazy. You know, once you start doing more complicated stuff, it can be a little crazier. So we have here is, this is an Arduino. This is a mini Arduino. It's basically just the same thing in a smaller package. And so, you know, right now this is only essentially tack soldered on one side of the header. If you see this, you can pull it. And so, you know, this is like the kit type of thing. I can put this in the holder here. I have to undo this. Oh, actually, I'll leave that where it is. I'm going to undo this one.
So Brian, sorry,
yes.
it was just a little blurry when you were doing the soldering. So you have the chisel on the one side of the lead, and then the solder is on the other. Is that?
Yep. Yeah.
Okay.
So
Right.
so essentially, if this is like the pad, and you've got, this is your lead coming through it, right?
Mm-hmm.
I don't know if I have anything that looks like a chisel, but I've got here's a screwdriver. Is that a bigger screwdriver? That's a bigger screwdriver. So pretend this is your soldering tip. You want to put the soldering tip here, both to touch the pad and the wire, and, you know, push down a little bit to try and make sure there's good contact. Heat them both up, and then you're going to be feeding the solder in this side. And the whole reason for that is that if you're feeding the solder in this side and you're heating up on this side, then the only way the solder is going to melt is if these two things are hot enough. So it's kind of like a safeguard against melting the solder before the joint is ready to accept it.
Thank you. Thank you.
No problem. So, so yeah, is this the side that's not ready? Okay, so I'm going to put this in my holder. This is a little bit tricky because this holder there's not a lot of room for me to hold. So this is the kind of thing, you know, things that can be frustrating about fiddling with this kind of thing. But on the other hand, it's so fun. This one, this side. So this side, I want to solder this top side here. So I'm going to put this in my holder, and this has a spring here. So I'm going to push it until the spring compresses a little bit, because then it'll hold it a little harder. So there we go. So now this is pretty well held. So I'm going to rotate this to get a better angle on the joint. So this is, you know, this is a little bit harder. There's not a huge pin coming through. The pad is even smaller than was on the proto board. But with a little practice, the other thing though is that this lead, the header pin is a little bit thicker, so it'll accept the heat a little more, and it will heat up pretty well. So we're going to heat that up, get some solder on there. Come on. I think I'm not heating the pin up enough. There we go. So not a lot of solder on that. You don't need much. Obviously, it's a tiny, tiny, tiny connection, so you don't really need much of anything. It just, as long as it melts. For future calls like this, I would want to get one of those like USB, microscopy type of things for this kind of thing. But let me try at least to show what a relatively okay solder connection looks like. I don't know if this is going to show up on the camera very well. I have to be able to see my own screen. Let me move my zoom over to where I can see it from my bench. How do I look at my own? There we go. I can full screen my own video. So this is I can go back and look at the other, where are we here? There we go. So yeah, that's pretty blurry. This camera's not fantastic for this. But so there's solder on there, and it let me just use my hands. It goes up like this. It's a curved kind of thing. So if we go here, these guys are not going to be easy to see either. Yeah, when we get a better camera in the future, we'll be able to show you a little better. But you want the solder to like suck into the joint and not be like bulky and round and stuff like that. You want it to really like vacuum into the joint. Part of also with through-hole components is that it's not just that it's attaching to the components. So you like have a hole and you have a pin, but some of the solder will actually go into the hole. And so, you might find that, oh my goodness, so much solder went in there and I can't see any of it. Well, it's attached inside the hole. This proto board, the pads are only just on the surface, but if you have like a quote unquote real circuit board, like one of these guys, you'll see on this corner, this hole is shiny and this side of the hole is also shiny. There's metal all the way through that. And on a circuit board, that's called a via. And they are sometimes used internally to the circuit board to transfer electricity between the layers. Yeah, if you have a circuit board that's professionally pre-made, often they will have metal coated vias, so it's actually easier to solder these because the solder will actually stick to not just the joint and the pad, but also around the joint in the hole of the via, and it will make a much better connection. So that's also something to consider. That's most of it. Oh, the too hot part. Sorry, I missed the too hot part. So obviously the one part of it is where do we exit full screen? Okay, share screen, desktop 1. So yeah, the too hot part of, or the too cold part of it is that you're not going to get a good joint and the solder won't stick and that sort of thing. The too hot part of it is the two main things you have to worry about are the pad can lift right off the board. Pads are made of fiberglass. So these are fiberglass sandwiches, and the pads are just like metal that's just kind of laid or stuck onto the top. If you keep the heat on the pad for too long, the pad can kind of like lift off like a piece of paper. And if you have that happen on a circuit board, like on this kit one, where was the little trash panda one? I forget where he went. Oh, here he is. So like if you're soldering to a pad on an already made circuit board and that pad lifts off, you're gonna have a hard time because now you don't have anywhere to connect that connection to. You might have to do something like scraping back the insulation on the wire that's leading up to the pad and solder to that instead. But yeah, that kind of stuff can be tricky. So that's the risk with putting too much heat on, is lifting the pad off. The other one obviously is destroying the component. So depending on what the component is, if you just heat it up too much, you can just fry it. So you want to make sure that that kind of thing doesn't happen. I did have one more example of something that I wanted to show you guys. Yeah, here it is. I showed this to Paul earlier. So you want to take care of the tips of your irons, and after a while you will want to replace them because they can kind of like wear away or eat away over time. But this is an example of a tip that kind of hasn't really been taken good care of. Can you kind of see the hook in that? So this metal in here has been kind of eaten away for various reasons. Never take sandpaper to one of these things because the outside layer of the soldering iron tip is different than the metal inside. It's hardened. So if you use sandpaper or get a gouge or anything in the tip, sometimes that can make it eat away a lot faster. So yeah, you can buy new tips, not just for having different sizes to do things, but because tips can get damaged over time.
Do you use that old tip for anything? I'm just curious.
I haven't used it in, I don't know how long. It's just been kind of sitting around. It had been used, and that's how it got that way. But I don't know. It's been sitting on my desk for like a year. I forgot it was even there. And I actually had to go get my other one today because it wasn't at my house. Okay. So yeah, at this point, I'll pause for soldering questions or anything like that.
Yeah, the floor's open. If anybody wants to ask, they can unmute themselves and ask. If you're uncomfortable with that, you can just put it in the chat. I guess I'll ask some questions. I guess that pen one that you were talking about.
Yep.
I've got a beginner's kit from Adafruit, and they sent this in, and this is good enough to get me started, right? Like, I mean,
let me see.
It says it's adjustable. Yes, sorry.
Well, it's because I'm sharing. It doesn't show me your screen. Yeah.
It's the pen one. It's the basic brown pen one.
Yep.
I mean, okay.
Yeah, it'll definitely get you started. The tip there. Can you show me the tip again?
It looks like it's just a regular pen tip.
It looks slightly chiseled. I think it's hard to tell, but is it slightly chiseled? It's not just to a point, right?
It looks pretty pointy to me.
Yeah, it's hard to tell from here. So yeah, that'll certainly help. I mean, the taper is fairly chunky, so that'll give you some good heat mass in the tip, so that it won't lose heat super quickly. The main thing about the pen ones is just that you can't necessarily solder like too quickly. Like that Arduino header thing, you might have to wait a little more time between soldering the joints for it to heat back up. I mean, those were small joints. It may not be actually that bad, but it's just if you get into like things where you're soldering components with bigger, meatier, chunkier legs, or the pads you're soldering to are chunkier, or if you're trying to desolder something off of a board that's like attached to like a heat sink or something like that, like a transistors or like MOSFETs, like special types of transistors that are used for doing higher current things like driving motors and that sort of thing. If you're trying to desolder one of those off of a board and there's still a heatsink attached to it, good luck with a pen one or any other one, because you're going to want to unglue that heatsink before you. But even just like transistors are, I don't know if I have one around. They're just kind of big, and they have a big metal pad on the back of them. I'm not sure if I have one to show, but there are some components that are just beefier, and a pen might just struggle to keep up with the demand of how much heat you're going to need to pump enough heat into that thing to get it to either heat it up enough to add solder to it, or heat it up enough to melt the solder that's on it.
Okay, thank you.
The solder braid can usually work in that. Sorry, the solder braid can usually work in that kind of situation, because you can heat up the solder braid and you can just kind of move it around to the different places the solder is, and kind of soak it up. So that might be a strategy for that. Yeah, you got some braid right there.
Yeah. They kind of give you a good kit, but they didn't give me that brassy thing or the helping hands. So I guess that'll be my next useful. Amazon pitch.
Yeah. Well, you can get them at like I mean, we're all in or near Barrie. Sayal has everything you're going to need. Down on
Sean has been giving some excellent links. Same with Chris in the chat. We appreciate it, gentlemen. But yeah, that was one of the first things Sean said, is they got everything at Sayal. Is that how you say it?
Sayal. Sayal. And they have there's one in Toronto, and one in there's a few of them around. But yeah, they have everything. They have down to components, individual, like a whole bunch of the common kind of like chips that you would have. I have one here that's a very common one. I have a whole bag of them. Where are they here? So this is a very common. Oh, I've got one out here. I don't know if you're gonna be able to read it, but this is called a 555 timer chip. So it's a very useful chip for a lot of applications. It's called a timer chip because you can configure it to basically pulse at different duty cycles and frequencies and that sort of thing. So if you wanted to do like a simple blinking light circuit, you would just have a 555 timer circuit. You solder up and connect up some resistors in a certain way, and depending on the value of the resistors, it will make and a capacitor. Basically, the 555 timer ends up charging the capacitor, and it's on, or I forget if it's on when it's charging or off when it's charging. I forget, but the capacitor charges and discharges, and this will output a positive voltage or signal on its output pin during those two phases. And so you can change the resistor values to make the capacitor charge up and discharge at different rates. And the pins are all arranged on here so that you can connect the resistors to the different pins and have that all set up. So 555 timer circuits are very, very commonly used in all kinds of electronics, and they're a very useful chip for a lot of applications. But there's logic chips and all that kind of stuff. You can find all that kind of stuff at sale. It's all there, as well as tools like all kinds of stuff. It's like the Princess Auto of electronics.
Does anybody have any questions?
Yeah, I have a question. So
Sure.
So I know you mentioned Arduino and breadboard and LED. Do you do this? Okay. So my question is very like a beginner kind of question. So how do you know where to connect the ground, the 5 volt, and where to connect the resistor? Because I've never done Arduino before. I just started it. And sometimes I try to code and then my bulb just like burst out kind of thing. And that's basically, I think, because it's the resistor, but I don't know why it does that. I don't know why, like, I just don't know anything. I just don't know where to connect it, why the resistor does that, how to actually understand it to begin with.
Right. Okay. So LEDs in general have a maximum voltage you could put through them. So most LEDs, it depends on what color it is, but on average, an LED you can put 20 milliamps through it, and if you overdrive it more than that, then you'll either shorten the life or just burn it out. So if I was to take a 9-volt battery, and I think I might be able to do a quick little demo. Do I have a 9-volt battery?
Can I share my screen?
Yeah, sure.
Okay.
Oh, I have this guy. That would work. Okay, go ahead.
Okay, so I have this. So I connected the ground here, and I connected the 5-volt here because the assignment told me to do so. But in real life, I'll be like, I have no idea why I did that.
All right. So yeah. So the issue here is that you don't have anything connected to your positive. So if you look, does Zoom have annotation where I can draw on your screen?
I believe so. My niece does it all the time.
Yeah, let me see where it is. Oh, I'm sharing my
screen.
It's here.
I think it's
view options, annotate. There we are. Cool. But now I can't see your screen. I've had this happen before. I'll show you on my screen real quick.
Okay, yeah, sure.
So I'll share mine, and then I'll show you what I mean. I'm on a Linux desktop, and sometimes the actually, well, no, probably sharing is going to be easier. So if it's a breadboard here.
Well, first of all, Emily, is your project shareable? Can like Brian bring it up on his screen, or?
Yeah, I can do that. I need to export, I guess, the code, right, Brian?
Yeah, probably, but it's the thing that I saw is kind of easy enough to show. Okay. So you had a resistor like connected along here, essentially.
Yeah.
So you're using your, okay, so let's start from the beginning. So this whole circuit in your case is getting power from the USB. So this is like your power in. So the power and ground for the whole circuit is from the USB. And then the power and ground, you may already understand this. I'm just kind of like making sure that we start from first principles.
Oh, no, I didn't understand that at all. You're doing a good job at explaining it.
Yeah. So you can use these pins to either supply power or to supply power to the Arduino, or for the Arduino to supply power to other things. Because really when it comes down to it, this 5 volts is 5 volts everywhere. So if you connected a battery to the Arduino on this 5-volt pin, you know, this 5-volt pin has 5 volts. It's at electrical potential of 5 volts, and then this one's at ground. But in this case, because you have your USB connected in, this is already going to be at 5 volts because, you know, the USB is what's providing 5 volts to the system. So what you're doing, let me there isn't really an easy way to do it, but I'll just move this up a bit. So if I go, on a breadboard, the idea behind these rails are like, if you want to connect anything to plus or minus or positive or negative, you just connect it out to here, but you have to connect the power to these rails somehow. And you only had one of them connected to, like, there wasn't anything connected to your positive rail on your breadboard. There was just something connected to your negative rail.
I think
so unless I missed something.
I think the ground was connected to the positive, and then the volt was connected to the negative.
Okay, let me see your screen again. I'll stop sharing.
Yeah. One sec.
Just assuming some of us are very beginners.
Yeah, so the ground was connected to the negative, and the volt was, yeah, I'm the like beginner.
Yeah,
okay,
so
go ahead.
So Brian, when you say ground, like follow us through, like the power comes in from the USB.
Yep.
It goes through the 5 volt.
Yep.
And then the ground is what completes the circuit.
Yeah. So right now, so you have the blue wire at the bottom that's going to the positive rail that's all the way along the bottom of the breadboard, but nothing else connects to it. There's no circuit, right?
I have a question. I'm sorry to interrupt you when you were explaining. So I have no idea why it's blue. I just put it blue for it to differentiate between the green, but I don't have any idea if it needs to be of a specific color. If it if it makes a difference.
No, I don't think it does. It's just decoration at this point. So okay, so let me just actually look at the whole. So you're using, so your button is on pin 2, and so you're using the button to trigger the light, and the light is on pin 13, correct?
The light is on pin 13.
So in your code, well, pin 13 on the Arduino. So pin 13 is what you're writing to. Yeah. So blue light pin is 13. So then, okay, so the easiest way to do this is just to follow the circuit. So so we'll start at 5 volts. So the 5 volt blue, well, it's easier to go the other way, I guess. So the ground goes to the resistor because it's connected to the negative rail. Then the negative rail goes to the switch, and the switch goes up to switch to number 2. Okay, so then the signal comes out of 13, the voltage comes out of 13. So when you make it the pin high, then 5 volts comes out of pin 13, goes back to it's row 8 on the breadboard above the light. So then it goes through the resistor, and then it connects to one leg of the light, and then the other leg of the light doesn't go anywhere. There's no circuit. It's you need one more wire.
Oh, okay.
So the row number 9 on the bottom of the breadboard has to go to negative.
Oh, okay.
So there's nowhere for the power to flow from pin 13 through the light to ground.
Okay.
So just try it now and see if it works.
So pin 30 goes here. So I need to create another pin, another
wire.
Yep. From here.
Yeah, from there to the ground right below it would be fine.
Okay.
So you can do it right below the light, the very bottom of that. You might be able to get a hold of that hole that's right at the bottom. Yeah, that works.
Do this.
Yeah. So now you have the whole circuit. So give it a shot, see if it works. We might have more to troubleshoot. So now you have to push the button, I guess.
No, it's not lightning.
Okay, so is there like go hit the debug, the little bug icon in the, like, I haven't used this simulator very much, but hit right above your, hit that guy. So add breakpoints by, oh, okay.
Yeah, I don't think there's an issue, because whenever there's an issue, it complains here, exactly like Visual Studio. It would tell me it has an issue, but it hasn't complained.
Well, I don't think the code is like has a bug or has a a syntax error in it. When debugging, the other thing is that you can use it for is to see what the state of your program is in the middle of it. So if you hit debug, and we're gonna pause it in the middle.
Sean
I'm sorry,
said,
I didn't see the chat here. Here you go.
Sean said, lead pin 9, your cathode is not connected on 9.
Oh, you have the light backwards.
I have my light backwards. This?
Maybe.
Both inputs are on the negative.
Or maybe
because you spun it around, you swap the legs. So try it now.
So,
and then push the button.
I was wondering if I should modify the code here. And that was like my next question, like what we did with soldering, which was a little bit of manual. I was wondering if where does the code part comes when you have an actual Arduino and breadboard?
Where does I'm not sure what you mean. Where does the code part come? Like you just put it in the Arduino.
Because here, yeah.
I've just played a little bit with beginner kits, but first you get your components all set up, and then you would use the USB to upload your compiled code to the board.
Oh, yeah.
Right? Does that make sense to everybody?
Yeah, so I can share really quickly
yeah, sure.
The Arduino Ide, the actual Arduino Ide, which is the program that you use to desktop 4? No, I'll do desktop 1 and just move things around. Okay, so you can see this thing, this guy, this window I'm moving around.
Yes, I can see.
Okay, cool.
Yeah.
I think people were breaking up or something. So this is the Arduino, like you don't have to use this to program Arduino code in, but the big thing about this is that it already has a lot of the stuff set up for it to upload the software. So you would do tools, and you can do what board you're going to upload it to, because they can all be a little bit different, and then what serial port you're going to be on, which this is in Linux. This is just what the USB port looks like as a device essentially. So then when you're done, you would just do upload it. You connect through that USB, the same one you're using for power. You use it for uploading the code, and then as soon as the upload process is done, the Arduino will immediately reboot and start running the code from the beginning. And that's it.
Thank you. Gotcha.
No problem. So let me try and recreate your circuit real quick and see if I can figure out what is going on. So I'm going to, can I just do a new one? Where is new? Go back to, I don't know. Where is the, go back to the, oh, there's more components. There's all components. Wow, can't wait to try that out. View hide to go to here.
You are unmuted, Sean, if you want to go ahead.
Okay, so new circuit. Okay, so we're gonna get a breadboard. We're gonna get an LED. We're gonna get a resistor and another resistor and a switch, and the push button's gonna go like that. Yeah, I guess almost certainly these are, yeah, okay. So get the Arduino, obviously, over there. Okay, so then can you paste your code in the chat?
Sure, 1 second.
No problem. Where is the chat? Hello, chat. More? There's the chat, okay. Whoa, there's a lot of stuff in there. That's a sad soldering iron. It sure is. Cool, that worked. Okay, Control C. And then code, text. Yeah, I'm okay with that. Control V, Oh, this is not formatted very well, but this might take a little bit of time. But the code's, oh, that's what I need to do. Here we go. Thankfully, it's not a very long program. It's got some stuff in it. So yeah, I'm just gonna try and pin mode. Can I make this bigger? I sure can.
I think so. Yeah.
Okay, void loop.
At some point, I don't want to ruin your flow here, Brian, but at some point, if you could maybe go to your dashboard on TinkerCAD and make this public so we can all tinker around with this. I don't know if it's a private project or if it's a public project, but you keep going.
I doubt it. Okay, so then I need these squiggly brackets. I need that squiggly bracket, or it's going to complain at me. Okay, so I'm just going to see if it'll run so that I know I edited it all properly. Okay, it's not complaining at me, so that's good. Okay, so I'm going to get rid of the code and I'm going to connect it all up. So we're going to do wires. So 5 volts to our positive rail, ground to our negative rail, and then we're going to have this guy. This will tell me, so cathode, anode. All right, good. So we're going to do, oh yeah, we got it. Yeah, so rather than putting it in line, I'm just going to put it like this. So pin, was it 13 for the controlling the light? No, it was pin 2 was the light, I believe. Pin 13 was the switch. Like so. And then we're going to go from here to here. So that's one thing about the code is if the button is high, then turn the pin high. So right now, the way you have this connected is that this is always high. Sorry, this is always low. Wait, no, actually it's not. It's digital right. I forget whether this by default makes it high or low, but basically when you push this.
Comment.
Yeah, go ahead. Or where is it? Where's the chat? I had it here a minute ago. Let me go get it again. More chat. My maker's working with looking at Emily's resistor on the negative rail as well as the LED. I guess share your screen. You must have missed something.
My settings could be wrong too, with the wires.
So confused. I'm so confused here. If you were going to walk through this, Brian, so I see the 5 volt go to the negative and we see the ground go to the positive so that makes sense, but
no, it's 5 volt to positive and ground to negative. You said it backwards.
Okay, sorry.
No problem.
I got that. Yeah, there. I'm going to get zapped one day. I just not. Okay, so 5 volt to positive, ground to negative. Okay, got that. But then we see up at the top there, the digital 13 goes to, what do we see? 8? Does that make sense? And
row
then,
8, yeah.
So what's happening there? Like, what's going on there?
Oh, yeah. Let me see the code again. Is it backwards? Emily, can you show us the code again? Yeah, the LEDs. No, the LED's 13 and the switch is 2. That's correct.
Okay.
But the problem is that the button, you're looking to see when the button goes high, but you're connecting the button to ground. So the resistor that's leading to the button is connected to negative. But if you wanted to make the pin high, you'd want to connect it through to positive. So that resistor that's the bottom left one, you want that to go across to the positive, so that when you push the button, you're completing the circuit to supply it power.
Sean says they're both negative.
Like this? Positive?
There you go. Okay.
Yeah, like that.
Should we run the simulator again? Let's see.
Yeah, give it a shot. It's a good time to try it.
Okay, it's complaining about this. I don't know why it's complaining.
Where?
Oh, you just had a break. Yeah. When you're
turn
in
off the debugger.
debug.
Just turn off the debugger. Yeah. It's single stepping. Yep, and then just stop it and start it again, or just press the button, I guess.
Okay, all good. Oh, it's turning on.
It's on all the time though.
Yeah, because it's. Oh no, I did put low.
Right. So that means that the button is always high.
Okay. So I need to turn the button low too. So
well, I think what you might want to do is connect the button back to low. I can't remember whether the default of the pin is to be high or low, because certain pins, depending on what it is, it'll default to either being high or low if you're not manually making it high or low. So if you put the resistor back to connect to negative, and then switch your if statement to be if, instead of saying if it's high, say if it's low.
Okay, sorry, 1 second.
No problem.
So if I switch it to, oops.
Yeah, just move it up one.
Oh yeah, I need to stop simulation.
Oh, okay. Yeah, for sure.
So
what does high like when you say high, is it almost like on?
Yeah, high is on, low is off.
High is 5 volts, low is 0, essentially.
Got it.
I had trouble with that too. It just turns on. I think the circuit is good. I just maybe need to play around with the code, with the if-else statement in the loop.
If digital read button 1 pin, button 1 pin is 2. Button 1 pin is input.
Set my switch to low. Which switch?
Or does it mean push the button? But that shouldn't work. That shouldn't do anything. Yeah. So the digital write to blue LED pin is always high. So that means that your digital read button 1 pin, your button pin is always high. So
yeah, I need to change this.
So it might be that you need a pull down resistor to make sure that it's always low, and then connect it directly to positive. Well, maybe not directly to positive. You might need a resistor there too, but yeah, I'm kind of stumped too. I haven't done Arduino in like 2 years since I did a.
That's okay. Like you actually explained to me the beginners part, which is very essential, I think, before starting to do that. I was just connecting wires everywhere, not knowing why. Now I know, okay, like the resistor is connected to this and the leg is connected to that. So it's like, you actually really helped me right there. Like, thank you so much.
Yeah, so if I'm going to look at the code on mine, and I mean, mine should behave the same way yours does if I connect it the same way. So I should be able to figure it out if I, how do I, there we go. Okay, so I'm going to do this, I'm going to do this, I'm going to connect it to negative, and then that, and then this guy is going to go to,
you haven't shared your screen, so we just assume you're doing it right.
Yeah, that's a good assumption. Okay, so share screen is where did Zoom go? Is it hiding? I think it's hiding. There you are. Share this guy. So I mean, this isn't the craziest circuit in the world, so it shouldn't be too hard to do. But I wanted to try. So if we start simulation, okay, I didn't copy it right. Is it missing a squiggly? So void setup. So I've got my opening bracket here, close bracket, opening bracket. If that.
Yeah, I missed a bracket from what I see in my code.
Oh, the void loop. I'm missing a bracket for void loop.
What's the default setting for the button?
I don't know. I'd have to look it up. It's been so long since I did this. Let me try and start again.
So you're missing a curly bracket instead of with your error there or something.
Yeah, it was, I had an opening bracket. I must have deleted one by accident. I had an opening bracket there, and then there was open, close, and then no ending close one for the loop itself. Yes, Sean, it is based on C. Yep. It does. I don't know if it does pointers and stuff like that, but yeah, it's definitely C style programming. Because you know the biggest clue to that is void, being the return value of the function. So this is kind of getting into the inside baseball, but when you declare a function in C, the first thing you write is what value does this function return? Void means I don't return anything. Yeah, it is definitely C. I don't know if you can do Java on Arduino. I'm not sure, but yeah, this is definitely not Java. But Java has a lot of things that kind of look like C. Like you can do, well, I don't know. I could get into a lot of different stuff, but like Java is object-oriented. Yeah, I mean, the thing is that you can use an interpreter that will take code from different languages and like, you know, going back to what an Arduino really is that way back when you wanted to do this type of thing, like this chip that's here is the brain of the Arduino. Like all the rest of it is just kind of like support hardware to make this brain work. So when you wanted to use one of these like 20 and 30 years ago, you just had the bare chip. And in order to program it, you had to put it in a separate programmer. It took a long time to program it. And then when you wanted to interface it to other peripherals or devices or anything like that, there's things like pull up and pull down resistors in here, and you know obviously the hardware to upload code and the hardware to supply power to it. Like this is a barrel connector where you can just plug in a wall wart, like a wall plug to this thing. So basically the big reason why Arduino is so popular is that you can use a microcontroller and all this stuff is built around it so that you don't have to do all the heavy lifting that you need in order to use one of these chips if it's just bare on its own, like soldering the whole thing to its own board and then soldering all these resistors in the right places so that all the pins operate properly, and having capacitors on the power pins so that line noise doesn't screw up your stuff. So but the thing is that the microcontroller doesn't actually run code that looks like this. It runs like machine language essentially. So the Arduino IDE, like when you program this code and you upload it to the Arduino, well, in programming there's something called compiling, right? So when you compile code, you're taking the stuff that you wrote and you're translating it into what the the operating system or whatever it is that's going to be running code is actually going to run. So so the Arduinos don't run this code you're actually looking at. They run their own machine code. And so you can use a bunch of different types of languages, and so long as there is an interpreter of some sort, like Sean was saying, CircuitPython, it will translate that code into the lower level machine code that's on the chip and allow it to run that. So you can kind of use your that was Paul. Oh yeah, sorry, yes. You can use a bunch of different languages to code stuff so long as there's an interpreter for it. And so, so yeah, that's part of the deal. So
is this circuit working now, or?
No, the light won't light up for me.
Oh,
so when I press this, so what I wanted to see though is if I turn on the debugger. So I'm going to stop the simulation. I'm going to start it over again.
You can put breakpoints and then hover over the variables to see.
Yeah, that's what I want to do. So if I, is it usually you click here to make a breakpoint?
Yep. And then there's let me see, there's something where you can step over and step into. Yeah, they tell you those two buttons.
So stop and then start over again. And then, so here's my breakpoint. And so then I can hover over blue lid pin is 13 and button 1 pin is 2. So that's the pin mode. Okay, so then if I this is step over next, I want to step into the next function. No, I don't want to do that. I want to go to the next, okay, loop runs factor, okay. Digital read, button 1 pin, high. It hasn't read it yet, so we won't know if it's high or low. So if I do step, so it does say that the button is high. I haven't pressed the button yet. So, I mean, for programming, doing debugging like this is almost essential. Like when you're doing Arduino code, like this is really, 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 really important to do, to do debugging, because it's really hard to, like, you know, just guess what the state of things are in the middle of your program when all you can see is what the output is. Excuse me, I had to cough. So being able to single step through things is really good. When you're debugging, another super helpful thing is, I don't remember exactly how to write it, but there is a way to, in the Arduino IDE, there's this thing at the bottom, this area at the bottom, and this is the console. And you can write messages to that. So you can say, you can get to this point of your program and you can say button value equals digital read button 1 pin. And you can see whether it's higher. You can put it in a variable and then write that variable out to your console. And so when your program is running, it will just constantly tell you if the button is high or low the whole time you're running it. Serial monitor here. This is where you're gonna, in this simulator, this is where you're gonna see that information. So when you're debugging, sometimes you'll sprinkle you know, those commands in there to write things to this output, so you can see what things are as the program is running. So right now we can see, because it stepped into this part of the block, then this button pin must be high. So it's going to write high to the LED pin. So if I'm writing high, first of all, if I write high to the LED pin, I'm going to stop the simulation. And where do I make the code go away? So if the LED pin is high, so then this is going to turn on if I go to ground, except I think I might light upside down. Is that right? Can't remember which way you had yours. Oh no, I can only go one way. Is there a control button to rotate it the other way, I wonder? Start simulation. Is my light not connected correctly? I can't, oh, my simulation wasn't running. I can't remember whether anode or cathode is the, check the battery. This is the battery, the whole computer is the battery. So it should be writing high to the resist to pin 2, unless I've got something connected wrong. Pin 2 should be high. So here's another thing that I'll show you guys, since we're kind of on the Arduino train. I'm gonna stop the simulation. Someone said that they're an electrician, they'll understand this right off the bat. This is a multimeter, and actually when I was doing the soldering stuff, and I'm actually gonna show you right now because I don't want to miss this. Are you guys seeing my camera now? For those of you who haven't used a multimeter, a multimeter is extremely useful for, it's a handy tool to have around when you're doing soldering. So multimeters have, you know, one major function is to measure electrical things like voltage, current, and resistance. But they also have this one awesome feature, which is this, on this one is the sound icon. And this is a continuity tester. So if I just take the leads of the meter and touch them together, then the multimeter beeps at me. And the reason it beeps is I'm just testing to see if these two things are connected to each other. So if I touch these two things to something that's conductive, like my sponge holder, it's saying electricity is going through that. So when you're soldering and you're not sure if that connection you made is good or not, you can put your leads on something. It's not going to work too well through a LED because LEDs have a voltage drop across them. Yeah, it's not going to give it to me, but those two are connected. So if you have like if you have a circuit, I don't know if I can do it here. Yeah, probably I can do it here. So you can see that like this spot, I think this spot and this spot are supposed to be connected. So if I touch the leads, I can tell that that's connected. So that means the solder joint is good enough that I'm getting connectivity between those two spots. So yeah, a multimeter is a very good troubleshooting tool when you're soldering to make sure that the things are connected. So in this Arduino circuit, we can use a multimeter to tell if stuff is flowing through the wires. So in the case of if you wanted to see if there's current going through it and how much current is going through it, you would go from pin 2, and then for current you put it in the way of the circuit, like in the circuit. For voltage, you make it parallel to the circuit, so you would do it like this. You'd have just the circuit normally, and then you would just put the multimeter attached to 2 different points, and it would tell you what the voltage is across that point. So like if this was 5 volts and this was 0, it'd say 5 volts. Or so if we do this and we start the simulation, I'm going to change this to measure current because it's not going to measure. So see, we've got no current going across there, so we know that nothing's happening. This volts, mode amperage. Why is it saying V? It's kind of weird. Maybe only once it measures something that it actually will do something.
We can't
see.
Oh,
it's back. It could be that it's backwards.
We can't see the screen.
Oh, sorry. Am I not sharing? Share screen. So here's the multimeter. Mode amperes. Yeah, so that's positive, and that's going to ground. So we kind of need it hooked around the right way. So amps. Yeah, so there's no current going through those wires. So if I do this, nothing happens. So I'm not sure what I'm doing wrong. I mean, I've got the pin 2, button 1, pin 2, digital right, blue LED. Oh, I've got the debug on, no wonder. It was stopping at one point and not going any farther. So this could be because this is backwards. Sorry, go ahead.
You have to show me how to make my multimeter chirp at me like yours.
Do you have one handy?
Yeah, I have this blue one here. So this was part of the kit from Adafruit. I just don't know the connections on the bottom here. There's four places. Yeah. I assume the black goes in the black, but then I don't know about the other ones. So
you'll have one that's common, which is the black one.
Mm-hmm.
Okay, common, yeah. So then, yeah, so you have the one on the right that says V and has that ohm symbol. So that's the one that you use if you're going to be measuring volts or resistance.
This one?
Then you have yep. And then you have one that says A and one that says MA. So the A one, you'll see it says 20A underneath it, which means the maximum you can measure with that meter safely is 20 amps. The next one over says 200 MA. So that's the maximum you can measure with that puppy is 200 milliamps, or it will, the fuse will blow. The reason that you have 2 different ones is because the one that measures 200 milliamps is a lot more accurate. So if you use the 20 amp one to measure like 15 milliamps, it's not going to be very accurate. And also the readout is going to be 0.015 instead of 15. So it's accurate, and it's you'll get more decimal places of accuracy. So in order to test continuity,
yeah.
you would plug into common and voltage.
So voltage
then,
being this one here.
Yep. And then
Okay.
I'm trying to look on your dial where if there's a speaker one. I didn't see it.
Yeah, sorry. I see just one of them has a musical note. I don't know if
That would be it.
One. Come on, serious. Let's see here. Nothing.
Someone's outside in front of a bonfire. So jealous.
Oh yeah, Chris, he's got the best
animated.
Anyways, we can cover this another time, but yeah, I got on the music note, tapping them together. It's not making a beep.
Maybe I got. I didn't see the display. Is it turned on?
It says
yeah, it's turned on. Okay, and you tap them together and nothing happens. Very interesting.
I'll do some Googling. Thank you.
Well, I mean, try it in the ampere one. Maybe it does continuity through amperes, but usually it does it through resistance. So by showing 0 resistance, that's how it knows that it's connected. So I don't know if it would be. I don't know why it would be that way, but it should be on the volt and ohm one. You can also just do it kind of manually, even if you don't have like the beeper thing in your multimeter. If you just plug it into the ohms one, turn it down to the lowest setting, like the smallest resistance thing, and connect it. And if it says 0, then you're connected, or something very close to it anyway. And conversely, like you saw when it said like it just had the number 1 there, that means like infinite resistance. That means like there's not connected at all. So if you have two things that should be talking to like connected to each other, and you put the leads on it and it just says 1 at you, then that means that there's nothing going through. Like put it on its highest resistance value setting, like mega ohms or whatever it is, and then put it on, and if you don't get any reading, then they are not connected. So I don't know why you're not getting music. Oh, do you have probes where you're not touching any metal together? You have hooks in those. No
hooks in them.
Yeah, you have to like pull them.
I have
covers.
Covers. Okay, yeah. I'm really new. There you go. Thank you.
I gotta hear the beep now.
Oh man, I'm so embarrassed. Okay, so I'm gonna put it in voltage and common.
Yeah, always in common, and then the other one is in the volt and ohms, or one of the other 3. There you go.
Yes.
Yeah, sometimes you let a little pressure on them. No problem.
Yeah. Thanks, man.
Okay, so I want to figure this circuit out. Like even if we end the thing, I'm going to figure the circuit out. I don't remember. I'm going to look it up because I'm LED, anode, cathode. Well, it's not even anode, cathode. Anode, cathode, positive. I don't even remember which is what. Positive is cathode, negative is anode. Oh, wait. Battery anode is negative and the cathode is positive. Longer leg is positive. Okay. So longer leg is positive and this shorter leg goes to negative. Okay, so this is hooked up correctly unless the wires aren't right. So okay, so let's see. I'm gonna make this one black just because it makes it easier to tell that things are cool. When I just realized when I said earlier that you can use 5 volts to supply power, that was actually incorrect. V in is where you would supply power. 5 volts and 3.3 volts are the supply out. So if you connect a battery pack or something like that to the Arduino to supply power, you use V in and ground. So that's why these two V in and ground are beside each other to be power supply, and then ground beside these two are for power out. I think it might still work if you connect power to 5 volts, but I'm not absolutely sure of that. Okay, so so our pin is low all the time. So what I'm going to do is I'm going to use a pull down resistor. I don't have this connected to here. So generally what you do with breadboards is you connect the negative to the negative like this on the end so that both rails are connected. So now my negative and positive are the same thing on both sides. The USB does need to be plugged in because I don't have a battery, but it automatically does that in the simulator when I start the simulation. It'll like do a little animation where the USB plugs in. Bypass the switch. Yeah, that's probably a good idea. So we're just going to do this. But yeah, I was going to do so if I do this, then I'm going to be, yeah, negative is going to go through to negative, so that's fine. So then this will definitely be low. So if I start simulation and I go to code, and then I'm going to do debug, and I'm going to do a breakpoint there. It's not stopping. I have to do it over again. So yeah, when I start simulation here, watch the USB over on the left. It goes plunk. Okay, so it stopped at 6. I'm going to go to this one, digital read. It still thinks that button 1 pin is high. So for some reason, we're not able to pull this thing low. So because it's a simulator, I can do crazy things. I'm just going to connect it directly to ground. So there's like no possible way it can't be low. It has to be low. So code, debug, start simulation, breakpoint. Next one, still thinks it's high.
Okay, here's a beginner question. The resistors, yep. you just grab them from the component thing, and it did give you an option to specify what kind of resistor. And is that all correct? You choose the right one?
I didn't bother looking at it because it's a simulator, but so you would do like the Ohm's law thing to figure out for an LED. So if I bring a calculator on the screen, so have you guys seen like I like the VIR triangle thing? It's the easiest way. I don't know if it's gonna. Yeah. So VIR. So when you're calculating stuff,
walk us through it, please.
This guy here. This one's the one that I like. Oh, this one works too, but I'll do this one. This guy. I want it bigger though. Okay, so that's you guys can see that. So if you want to know one of them, then the position of the other two tells you how to figure it out. So if you want to know resistance, then it's V over I. If you want to know current, it's V over R. And if you want to know V, it's I times R, right? So and the basic unit is 1 ohm, 1 volt, 1 ampere. So like you can't, it's not like 1,000 resist, you have to use the same units, obviously. So, if it's 20 milliamps, well, the standard unit here is 1 amp. So that's 0.02, not like 20 or something like that. So what I'm going to do is I'm going to do the calculation of figuring out, where did my calculator go? Hello, calculator. Oh, by the way, that's a picture of the Mars rover landing on Mars from the rocket backpack that it was using. They got some amazing pictures on that thing. So that's really weird. My calculator won't come up. Let's make a new one. Okay, so I have 5 volts, right? So I want to know how much resistance I need on my resistor in order to give me 20 milliamps. So I know 20 milliamps and I know 5 volts. So I'm going to say 5. I don't have my num lock on. 5 divided by, and it's 20 milliamps. So there's 1,000 milliamps in an amp. So you're going to put 0.2, 2. So you could put like 2 zeros. So like 20 of 1,000, 20 milliamps, and then you put equals 250. So if I want exactly 20 milliamps, I need a 250 ohm resistor on a 5 volt power supply. So in the simulator, these are like 1,000, I think was what the default was, if I remember my color codes right. So I don't know if I could go into resistor color codes, but it's brown is 1, black is 0, and then red is 2 more zeros, so it's 1,000. So that's 1 kilo ohm, 1,000 ohms. So if we bring over this guy, and now we go backwards, we're going to say I've got I have the resistor and I have the voltage. How much current am I going to get? So if I do 5 divided by and 1,000 ohms, I'm getting 5 milliamps. So 5 milliamps will drive an LED. So, the resistor is close enough. And you might not, it can handle 20 milliamps. You might not want to always put 20 milliamps through it. But, obviously more current means more brightness too. So it all depends on what you're looking for. So, 1,000 ohms is probably fine. But just because we can, I'm going to do 250 ohms. So now you see the color code changes. 2, 5, and then 1, 0 is how color codes work on resistors. So I'm going to stop the simulation. Make sure everything's kosher. I'm going to get rid of this guy because I don't really need it right now. 2, digital pin. Okay. So code, start simulation. I got my breakpoint. So let's see. Do I go into the... Yes, I do. So I'm going to look up real quick. Arduino set digital pin initial state. What is the default setting for a digital output pin? Pin start in input, high impedance state. If you put pin modes to pin output, the pin turns to output low. However, if you first set the pin to internal pull up and then to output, the pin's up in the output high state. So what that means is that this is like the thing about having infrastructure around the microcontroller to help you do things. So what that essentially is doing is that there's like a little resistor embedded in the board. And if you issue this command about having you set the pin to input pull up, that means that it activates a little resistor in the actual board itself, so that it basically connects that pin to positive all the time, which makes it high all the time. So we're doing pin mode pin output. I mean, you got light out of your circuit. So one thing we can do here is just simplify things. So I'm first going to just try to get the light to light. I'm gonna move this out of the way. I've got I'm going to connect this directly to negative. I'm going to connect it to positive. Well, no, actually, my code says that if it's high. So I'm going to say if it is low, then turn the blue pin on. Okay. So I'm connecting this thing directly to ground. This pin 13. Is it digital?
Sorry,
right pin,
that
right?
first setup there. Walk us through the setup here. So pin mode, blue.
Oh, okay. So pins can be either input mode or output mode, and it has to do with whether they're set up to supply power or not. Essentially, they have to be in the correct state, the correct function, in order for the circuit to function properly.
So the stack overflow. What did the stack overflow? What did it say? It said
on Arduinos, pins start in the input state, which input means that high impedance basically means high resistance. So like it doesn't just let electricity come through the pin and just go into the board. It's got a resistor there to keep the free flow of electricity from just going into the board. So okay. So pins start out in the input mode, and then when you switch them to the output mode, the initial value is the output would be low.
Gotcha. Okay. So the setup is correct.
So button one pin is 2, and then button 1 pin is set up as an input. Mm-hmm. blue LED pin is set up as an output. Okay. Digital read button 1 pin is equal to
took away
low.
the button. You took away the button though.
Where?
So this code,
Oh yeah, I took the button out, but it's still the pin exists. There's no button, but
gotcha.
It's just
okay.
a pin.
Okay.
Like you could just put like the numbers 2 and 13 in here. It's kind of just a way to, you know, make things more organized and readable. So I'm gonna have 13 directly connected to ground. So that should definitely be low. No, it still thinks, oh, it is low. Yeah, okay. So now the blue pin is being set to high. But I don't have this connected here. So I'm going to stop simulation. I'm going to put my resistor back, and I may as well make this one 250 as well. 250 ohms. Okay, we'll start
Sean
simulation
says
again.
Sean was calling this from the beginning, he says. Oh no, what is he? He gave us links, all right.
What is Multisim? I'm not simulation software, I guess.
Yeah,
oh,
just opening it up.
I think he's
like a
talking about a specific simulation software.
Gotcha.
Not sure. Okay. Okay, so that's working. So my light still isn't on though. So that one is positive. I'm going to go to, so blue high. So that would be low. So this is going to be going to here. Yeah, and then that's going to be, so when I set it high, then I'm going to get power through to that.
Should you put the button back?
Yeah, I'm going to try putting the button back now and see if I can get it to at least skip over this when I push the button.
Sure.
I'm not sure why the light isn't lighting up, but that should be easier to figure out. So now, this would be needing to connect to positive because we want to drive it high. However, I'm going to be connecting the positive and the negative of the circuit directly together between a 250 ohm. I'm basically going to be shoving 20 milliamps through this resistor, which, you know, not necessarily that, but I'm just kind of checking to make sure that it's not going to break on me. Okay, so I don't know if I press the button if it stays that way while it's like, how do I single step while the button is pressed? I don't know. So let's see if
you could put a breakpoint where it checks, and then run the simulation, push the button, and then it should stop at that breakpoint.
Yeah, that might do the trick. So, well, yeah, that's another thing is that it'll never stop here if it, like, you know, the fact that it stops at that spot means that it went low. Like, you know, it'll just ignore you until it goes into that block. So long as button 1 pin is low, it won't stop. So I do this. Yeah, it's not going high. All right, well, at this point, I'm kind of stumped. I'd have to do some more research and get back into Arduino programming, but hopefully that'll get you started on that kind of thing. But yeah, I like this tool. This is very interesting.
Yeah, it's awesome. So just so that in the spirit of trying to bring some of the free code camp into the works, I'm going to share everybody a circuit I've been stealing and borrowing from other people, and I'll put it in the chat. And I don't know how much time or energy everyone has, but this will be your homework if we don't get to it today. So I gave the link there. I don't know if
Okay.
it's It's loading up. Oops, what's going on there? Sorry, that page is missing. Let me see. Let me check. Let me see if it's. This is the one thing I had to keep seeing if it was in public mode.
This is the circuit that was a lot easier for me to make. Three
All right,
wires.
show us. Yeah, show us that. Show us that.
This one, easy peasy.
Nice.
So the code. This is just one of the examples that comes in the Arduino Ide, and you can kind of see here how things kind of work. So I could go into how servos work, but basically the pin gives you, based on how fast the frequency of the pulses down the pin are, the servo will point either between 0 or 90 degrees. So that's how you do positional control with the Arduino. So this thing is basically going between, it's 180 degrees actually. So it's going between position 0 and 180 and back and forth with a 15 millisecond delay between each step. So did you get the new link?
Yeah.
How do you get to the Arduino page? Do you mean the code thing?
Yeah.
Code
Sorry.
challenge?
Let me try that again. So yeah, this is the. See if that works for everybody. If you can load that up. It does say it's public, so it should load up. Let me do a little experiment here. See if it loads up for me. Yep, that one worked. Okay. So I don't know if you can see it, Brian, in the chat there. Or I can share my screen. Well, we'll let you walk through.
Ooh, interesting. Cool.
Okay. So this is I took a starter which showed us how to wire up the LCD to an Arduino. Mm-hmm. And then I stole somebody's code to incorporate a keypad so that you can do basic calculator functions just using that 4x4 keypad.
Awesome.
So run the simulator, and I had to tweak it because there was missing code or missing logic to run multiple. Yeah, steal the code. Go for it. Yeah, I definitely brought off and I did give credit in the code at the top there to the person that so you want to hit the percent sign there. That'll give you a simple calculation. Now try to run another one. This was the missing logic originally, is that it wouldn't do a few operations in a row here. So try that again.
Is there a clear? Star is clear.
Star is clear.
6 times. Oh, clear. Clear.
So there is some missing logic to get this to running now.
I think it's not registering on my presses very well. So if I just do 5, whoops, why did it give me a 9? I think it's the mouse is just not behaving for me.
What? It could. Minus. Everyone do your testing to see what the bugs are.
Or it's buggy, maybe.
It's probably buggy as hell. Slapped together in a matter of minutes.
I think I might see one thing. So if I do 5 plus 6 equals 11, and then I do.
See.
Yeah, so it is doing that. The first number you type in, it always puts something else there first. So if I do 4, I'm going to do clear. So if I do 4 plus 7 equals 11, and then if I do 8. So the last number of the previous question always comes up as the first, like gets typed here. I don't know if it actually, so I do 8 minus 5, 789. Okay, yeah, so there's something weird going on.
Okay. Anyways, so it does need to be tweaked a little bit. For our purposes, I was wondering if we could grab one of the coding challenges And I just found, I'm just going to pick one. So I'll share my screen if everyone's all right with that. Everyone see my screen? All right, so this is freeCodeCamp. If you ever get a chance, I highly encourage you to check it out. And I will go to the curriculum. And we honestly could steal several of the challenges from the interview section, but I think it would be in our best nature to steal something in the JavaScript algorithms and data structures section.
I've been doing JavaScript for 2 weeks for work, so right up my alley.
There you go. All right. So we could do something simple like convert Celsius to Fahrenheit with this Arduino simulator, or we could factorialize a number. So what do you think? What kind of coding challenge do you guys want to take on here? Let me see. Let me pick a good one here.
I love regular expressions, but they're kind of prickly. So like in concert with this circuit, essentially? Yeah. So like I would say something like, you key in a sequence, and it will, like an easy one would just be to reverse it, to just spit it out backwards. Or if you want to do something more complicated, it might be a good one like return the largest factor or something like that, if you get some math in there.
All right, how about this one here? Factorialize a number. So they give you the setup here. So return the fractional of a positive integer if the integer is represented with a letter n. A factorial is the product of all positive integers less than or equal to n. So it gives you an example. So
factorial, not factoring though. Okay.
Sorry, factorialize.
No, I just read it wrong. Like I thought it meant to like give you all the multiplication factors.
Gotcha.
Not to
Sorry.
do 5 factorial. Yeah. Okay. Cool.
So what I would like to do is incorporate this challenge into this circuit.
Uh-huh.
Do you guys think we could pull it off within an hour? Yay or nay? I can't see expressions.
Probably could, but my time is running out. I've got to get some kids to bed.
Okay, so then I'm going to assign it for homework for everyone. So what I want you to do is to take this challenge here. So I'll paste this into the chat. I'm actually getting a little tired myself. But oops, sorry. Sorry. Ignore that. Where the hell am I here? I gotta stop sharing screen to chat. Where do I go? You'd think I'd be a Zoom expert by now. So I've been a year and a bit of the pandemic. Okay, so you guys all have the template. There's the challenge. Bonus points make the answer scroll backwards and forward. Oh, that would be amazing. Liking kids like, yes, that would be cool. In the interest of releasing Brian so he can do the bedtime routine, does anyone have any questions for Brian? I had a question about my multimeter, and it just happened to be that I didn't know how to take the covers off the needles. But is there any questions that you can put in the chat or ask?
In your defense, you knew how to do it. You just didn't know they were on.
I'll take it. Yeah. Is there any questions? Arduino and accelerometers. I hope I'm saying that correctly. Do you want to comment on that, Brian?
Oh, so yeah, accelerometers like, so basically you would just, you would get an accelerometer chip. Like you can get, it's basically an accelerometer is basically just a chip, and when you supply power to it, it will give you different binary values out of a set of its pins based on the acceleration it's detecting internally on a certain axis. So you can get accelerometers that have different like 3-axis accelerometers, and it's basically just a chip, and you know, as it moves around, it'll the binary output will change to tell you what acceleration it's feeling on different axes. I think you can get ones also that will just give you like angle, like different like angle change from when you turn it on, kind of thing. But yeah, it's basically just a chip, and you read the binary output. So you would basically poll it, and also we didn't really go over this, but on Arduino there's a couple of there's a couple of different ways to talk back and forth between it and other things. If you look at the pins on the Arduino, there is the top right, there's a TX and RX, so you can use those for like serial communication. There's something called I2C, which I don't see it on the pins, but I think you can use or I2C as a communication protocol with some chips and that sort of stuff. So it depends on what the chip supports, but the Arduino can probably talk to it. Are there Bluetooth connect bits? Sorry. Go ahead, Emily.
No, I was just reading the question. You got it.
Okay. Are there Bluetooth connect bits? So with Arduinos, I think, yeah, with Raspberry Pis too, they have things called either hats or shields. So I could probably just bring a couple up. I'm not sharing my screen. Let me share my screen. So they're basically things that are their own circuit boards that have pins that just fit directly over top of the board and add extra functionality to it. So so like popular Arduino shields and hats. So here's, oh, there's SparkFun is a good place to get some stuff. So slow. Okay, so these are things that like the pins just line up with the Arduino itself, and you can get ones that will do all kinds of crazy things, you know, TFT screens or SD card readers or a wide array of things, including Bluetooth and all kinds of stuff. Like this is a power interface module where you can like control relays. It's got, you know, driver pins on it or MOSFETs, that kind of thing. This one's got a huge heatsink, so this is probably some sort of a driver one. So yeah, you can get stuff to do all kinds of things. The sky is the limit.
I got a question about some of these shields. I did order a shield, and it didn't have the, like, I mean, I'd have to take it out of the bag to show you, but I believe it's I did buy a Wi-Fi shield, and it doesn't have the headers attached to it yet, but it did come with a strip of them.
Yep.
Is that like advanced level
soldering? Is it just one
soldering.
long strip?
Yeah.
Yeah, you're just supposed to cut them apart. They just, you know, didn't bother cutting them for you.
Okay. No, just kind of following your tutorial and kind of go through the whole, solder them.
Yeah, tack one on one end, and maybe then like tack one on the other end is good, and then go through it. If you have a good pair of like small bladed side cutters, those are the best things for cutting the headers apart without damaging them or anything like that. One other thing to watch about with the headers is that those pins are not very like super well secured in the plastic like part of it. So if you push on it or anything like that, the pins can slide through those depending on which ones you get. Yeah. So you just take that and you'd measure like, you know, how long you need to go in the different parts of the shield, and just snip them apart.
And I know this seems like a basic question, but the long end, would that, like, which
solder the
side
short
would I
end
use?
on. You solder the short end on because you want the long end. Yeah, you want the long end to be able to put your hookup wire on. Or in the case of a shield, those long pins are supposed to go in the connection points in the Arduino.
Gotcha.
So those pins go right in the other holes, and then yeah, so you solder the short ends on. Yeah.
And I guess kind of a related question: do you prefer shields or do you prefer like breakout boards? Or
it
just,
all depends.
I guess, depends on the project.
All depends. Yeah. Okay. Like sometimes it's easy. Like, you know, if you if you're putting it in an enclosure and a hat or a shield is too tall and you just want to put it beside instead of on top, like it all depends. Shields are just really, really convenient because you don't have to do any wiring. You just solder on the headers, plug it on. But the other thing though is that sometimes with a shield, then that takes up all the pins, and then you don't have access to the pins to put your own stuff on. So sometimes you'd like to not cover up the whole Arduino so that you can still get access to the pins. Although then again, some shields, even though they plug into the Arduino below, there are then again more sockets on the top for you to still be able to plug things into. So it's kind of like a pass through where you can still connect to the Arduino pins. Like this one I'm looking at right here. Like there's pins all along the bottom here to connect into the Arduino itself, but then you can still connect into these pins on the top. So you still have full access to all the Arduino pins that are there. So it all depends. Shields are just really, really convenient. Probably I would default to a shield if there was one and there wasn't some strange reason why it wouldn't fit or something like that. But yeah, shields first, probably almost always, if I could.
Okay, and I want to respect your time here. Can you just give us a plug for your group? BRIX,
sure.
BRIX works.
So facebook.com Made in Barrie. Oh, this is notifications. I just want Made in Barrie. So I'm done. So yeah, we're a part of a group that is, a bunch of makers and stuff like that. And we are trying to make a makerspace in Barrie. We have been for a few years. Obviously getting location that is the correct type of location at an affordable price is a challenge, but we're working on it. The biggest thing we've got going on now is there's a pinned post at the top of here. And even if you don't fill it out yourself, we would love for you guys to send this to people that you think might be interested in a makerspace and fill it out, because the big push we have now is while COVID is happening, we're trying to gather data and get everything prepared for when we can actually do this kind of thing. And part of that is getting data so that we know who's out there, what they want to see. Let me actually go to the survey. I'll show you what it looks like. So we already have a bunch of answers, but like, what age are you? Where are you? What kind of, training, schooling do you have? And the big thing is, what do you guys want in the makerspace? This is the biggest thing is, we're not going to put stuff in there that people don't want. We definitely want to put stuff in there that people do want. We want the tools in there that people are going to use, to get a critical mass of members, and to make sure that there's stuff there that's interesting for people to work on. We're going to be doing workshops and all kinds of cool stuff. And so far the leaders in these are woodwork, the two woodworkings, 3D printing, textiles is pretty good, welding is pretty high, and visual arts is pretty high. And the rest of them are a little lower, except maybe for pottery. So, but there's interest in all of them, and we want to build a full service makerspace that has a bunch of stuff for everybody to use. But of course, the challenge with any makerspace, and I've been to a few of them, is getting that critical mass of people and getting a space that you could outfit to do what you want to do. So yeah, that's what we're working on.
We'll definitely spread the word and share. We appreciate.
Can we have like a link?
Yeah, I'll put it in the chat. The Facebook. We're working on it. We have a website, brix.work, but it hasn't been updated in a long time. So we're actually building a new one as we speak. That's another one of these things that we want to get going during the lull, and have that ready, because we want to do stuff like if we have a workshop, we want to propose it, see who's interested, and then wait till we have enough people who are actually interested in actually doing it, and then have a time where everybody can go. So it's not like something where somebody proposes a workshop and then 2 people show up because it just wasn't on the right time, or a bunch of people couldn't go at that specific time or something like that. So we want to build a website that services all that kind of stuff, and one of the biggest things about makerspaces is community, not just like building stuff, but it's the community and teaching each other and helping each other out and all that kind of stuff.
And where could people find you or the group?
So Brian at brix.work, and also at regular email is that. And yeah, that's basically it. You can email me at those emails if you want anything. BRIX has a Discord channel. We're not necessarily opening up to everybody yet, but if you want to talk with these kind of people, email me, and I will almost certainly give you a link to get in there and talk to like-minded maker type people.
Sounds amazing. Well, thanks
and
again,
we're going to
Brian.
try and do some online meetings soon.
Okay, well, we'll definitely attend those. I know I need them.
Yeah, we're going to try and do more like project-based stuff if we can. Like, we're going to do this and it's already tested and all that kind of stuff, and have something by the end of it. I mean, it's kind of harder to do online, but there's definitely a lot of stuff we can do. I'm big in 3D printing, so that might be something that we start with if that's of interest to people.
Yeah, I definitely would like to learn more of the nuances.
I would love.
I understand
to.
you. Cool. Yeah, you just press print and then something magically happens. And I've had some friends
if
say,
only.
"No,
that's not even true with regular paper printers."
Yeah, it's a whole learning curve. It's like, oh, really? Yep.
Yeah, but the whole curve is fun.
Yeah.
Yeah, it's hilarious. Like a foot to the right of where the camera's pointing at my desk is my Ender 3 3D printer that's had some modifications and stuff to it. So, and I've got a whole bunch of like example 3D prints that either have failed or are weird or just just for fun.
Well, so, I would definitely attend that workshop,
cool.
And I would definitely spread the word because I think that's I think people are dying
Barrie's
to learn
big enough
this stuff,
that we need one of those. Yep. Okay. Sounds good.
Yeah. Thanks again. And thanks to everyone that showed up. We have some regulars, some devoted people showing up, so that's good. We're getting some.
When's the next meeting?
Buzz here. We're gonna aim for the last Friday of every month.
Cool.
And we're gonna keep going until people get flat out bored of me. But yeah, no, I hope to keep this energy and buzz going, and it's a fun crowd. It's a fun crowd to share stuff with. So.
Okay, sounds great.
Thanks again, everybody. Please stay safe, and thanks again, Brian. I'll be sending you a little thanks your way. Thanks again, Emily, for helping moderate and bringing that excellent project. I think we're all going to be tinkering to get that LED light going. So
I know I will.
Thank you. All right, everybody.
Guys, I'm out.
Stay safe.
See you guys.